is solving rational equations we're going to talk about today, which are equations that have fractions in them, okay? Then tomorrow we'll do absolute value equations, and then those two pieces together are going to make up one homework assignment for you. So when you go into Math Excel, it's going to say 1517, today rational, tomorrow absolute value. Tonight, if you want to start on homework, you can just do all of the rational equation problems, skip the absolute value ones, and then come back and do the absolute value ones tomorrow if you want. All right, so rational equations are going to look something like this. This is an example of one that happens to also be a proportion, where we have two fractions set equal to each other. So you guys actually did problems like this, maybe back even in like Algebra 1, where you have two fractions set equal to each other. How do you solve that? We know how to do that. What do? Cross multiply. Yep. Okay, and then you're just going to have to be careful with your algebra, but nothing crazy is going to happen here, okay? So we're going to cross multiply. Make sure you might be distributing, you might be foiling on these. If I multiply, actually, let me write it out. X times 4x plus 3 is going to be one side, and then 2x plus 1 is going to be multiplied by 3x plus 2 on the other side. Okay, on the left, I'm just distributing x through, which is going to give me 4x squared plus 3x. On the right side, we're foiling, so I'm going to get 6x squared. My outside terms are going to give me a 4x. My inside terms are going to give me a 3x. So if I put those together, I'm going to get 7x. And then my last terms, 1 and 2, are going to give me a 2. All right, so now you see we have a quadratic. Nothing new for us, right? We practice this a lot. If we want to solve a quadratic, we got to get it equal to 0. I would recommend trying to keep that squared term positive. If the squared term is negative, it makes it harder to solve later. So I'm going to shift everything over to the right side to make sure that my squared term stays positive. So 0 equals, if I subtract the 4x squared over, I'll get a 2x squared. And if I subtract the 3x over, I'll get a 4x. And it looks like that once I get it equal to 0. What do you notice about all the terms in this problem? Everything is, yeah, divisible by 2. Take a 2 out. So I'm just going to divide everything by 2. 0 divided by 2 is still just 0. I'm going to have an x squared plus 2x plus 1. And now my choices are, because there's 2 x's here, I can either factor it or use the quadratic formula. Is this factorable? Two numbers that multiply to 1 and add to 2. Yeah? What does it factor to? Yeah, x plus 1, x plus 1. So if I set that equal to 0, I get just one solution that occurs twice. X equals -1 is my answer. How could I check that answer?
Plug it back in.
Yeah, it's the beauty of an equation, right? We plug it back in, we make sure it works. So let's just check one so you can see what that would look like. If I was going to, and we won't do all of them. If I wanted to check it, I would plug -1 in everywhere I see an x. So on the left side, it'd be -1 over 2 times -1 plus 1. On the right side, it'd be 3 times -1 plus 2, and 4 times -1 plus 3. So on the left, I'll have -1 over -1. So I'll get a positive 1. On the right side, I'll have -1 over -1 also, which is 1. And as long as I get the same thing on both sides of my equation, it checks. Yes?
On the left side, the third and fourth step, where did the 2 go?
This 2?
Yeah.
So I divided everything by 2. So 0 divided by 2 is still 0. Divide that by. You can also just factor it out if you want to. And if you factor it out, it doesn't give you any extra answers because there's no x there. So that's the other option on that step. Okay? Other questions on that one? All right, so if it's proportion, we cross multiply. That's it. So now let's see if it's not a proportion, where we don't just have two fractions equal to each other, if we have several fractions that we want to deal with. All right, so 1 over 6 plus 1 over x plus 1 equals 1 over x. Okay, so ideally, I want to be able to compare both sides of this equation. In order to do that, I want to be able to put my fractions together. What do you need to be able to add or subtract fractions? common denominator. And ideally, I don't just want a common denominator on the left side. I want everything to have the same denominator because it's going to make my life easier. What is and you could use any denominator, but ideally we want the least common denominator because we won't have our numbers that are like super huge when we're solving then. So what is the least common denominator between all three of these fractions? 6x and then additional x plus 1. So if I just had, I can't just say 6x plus 1 because x is not a factor of x plus 1. These are three things that all have different factors. So when in doubt, if you're not sure what the least common denominator is, just use all your denominators. It'll be bigger, but it'll at least be a common denominator, okay? But those are all the different things that I would need to create a common denominator between all three of these fractions. Here's how we do it. There's actually two different ways you can do this. I'll show you this way first. Okay, first thing I can do is multiply each fraction by what it's missing. So this first fraction has the 6, but it's missing the x and the x plus 1. The x and the x plus 1. Whatever you multiply by, you need to multiply by that on the top and the bottom, so it's just like multiplying by 1. Okay, the second fraction has the x plus 1, but it's missing the 6x. So I'm going to multiply that guy by 6x over 6x. And then the last fraction has the x, but it's missing the 6 and the x plus 1. Okay. Good so far? Any questions so far? Okay. Each of my denominators is 6x, x plus 1. And I'm just going to leave it like that. 6x, x plus 1. Whole goal of this is to get that common denominator. Okay. The numerator now is what you really need to simplify. So in the first fraction, I need to multiply 1 times x and then multiply that by x plus 1. Well, is it going to change anything if I multiply by 1? No. So really, I just need to multiply x through there. So I'm going to have x squared plus x. That's it. In the second fraction, 1 times 6x just gives me 6x. And in the third fraction, I have, again, 1 times something, which isn't going to change it. So I'm just going to distribute that 6 in, 6x plus 6. Okay. Now, because I have all the same denominator, I'm going to take this big fraction, I'm going to multiply the whole thing, both sides, by that denominator. Every fraction is going to get multiplied by that denominator. And that denominator that I'm using is technically on top right now, okay? Because it's on top, and this guy's on the bottom. When I distribute through, what's going to happen in every single fraction? It's going to cancel. It's going to cancel out every single denominator, which will leave me with just what I see in the numerator there. X squared plus x plus 6x equals 6x plus 6. So it gets a little messy in those first couple steps getting that common denominator, but if you're doing it right, at that point, once you have the common denominator, they all cancel. Really, as long as all my numerators are equal, this equation is true. So we're just setting the numerators equal to each other. All right, let's solve the quadratic. So I have x squared plus 7x equals 6x plus 6. I'm going to shift everything to one side. I'm going to move it to the left, again, to keep that x squared positive. So it'll be x squared. If I subtract 6x, it'll be a minus 1x. If I subtract 6, it'll be a minus 6 equals 0. Does this guy factor? Two numbers that multiply to negative 6 and add to negative 1. Multiply to negative 6, add to negative 1. We can do it.
That one's positive.
It's gonna, oh, it is positive. Yep, that's my bad. Thank you. Okay. Multiply negative 6, add to positive 1? Yeah.
X plus 3, x plus 2.
Got it. So my solutions are negative 3 and positive 2. And then you can plug them both in independently. So you have to plug negative 3 in for all the x's, make sure it works. Plug 2 in for the x's, make sure it works. Okay? What questions do you have on that problem? So in the next one, I'm going to show you how you can shortcut that a little bit where it gets messy with all the common denominators. All right, so let's write this one down. X over x minus 1 minus 1 over x plus 1 equals 2x over x squared minus 1. Okay, first, if I have subtraction between my fractions, I don't love that. It can get a little messy. So what I would recommend is change it to a plus and just make the fraction negative. Put the negative in the numerators. You can put it in the numerator or denominator, but numerator is going to be easier. Okay, so instead of minus, we're going to do plus and negative there. I'm looking for a common denominator, which right now I could say it's x minus 1, x plus 2, x squared minus 1. But if you know your factoring, you know what x squared minus 1 is equal to. What is that factor to? Factors to? It factors conveniently to x plus 1, x minus 1. So if I think about it like that, I have less I have to worry about as far as a common denominator goes. My common denominator is already on that last fraction. It's x plus 1, x minus 1. So really, I only have to multiply something into the first and the second fraction, which we could do just like the last problem, okay? And actually, let's write that down. The least common denominator is that x plus 1, x minus 1. Okay, this is the other way to do it if you don't want to multiply each fraction and get a common denominator. As soon as you know what the least common denominator should be, we are just going to multiply everything by it. We're going to kind of circumvent creating that common denominator. We're going to multiply it through. Okay, and remember, we're multiplying it. It's in the numerator, one's in the denominator. So it's getting multiplied by everything in the numerator. Denominator is staying the same. What should happen if you're doing this right? Each time you distribute it into a fraction, something should cancel. If I put that x plus 1, x minus 1 on the top, there's also an x minus 1 on the bottom. So I would only be left with x and x plus 1, because in that first fraction, the x minus 1's cancel. In the second fraction, if I multiply it through, again, I have a negative 1, I would have an x plus 1 and an x minus 1 on top, but there's also an x plus 1 on the bottom. So in this fraction, the x plus 1 cancels, and everything else I'm left with. So negative 1 and x minus 1. In the third fraction, x plus 1, x minus 1, both of those are in the denominator. So they both are going to cancel, just leaving me with 2x. Okay, does that make sense? Okay, so that factor I'm multiplying through is in the numerator, and it's canceling something in the denominator, and we're just writing what remains. This line is the same line you would get if we used the other method and got the common denominator and then multiplied that common denominator by both sides. It just saves us a little bit of like messy work in the middle. But if you like the other method better, use that. You can get the same thing. This is ultimately what's going to give me my answer, though. All right, so I'm going to distribute the x in. Distribute the negative 1 in, so minus x plus 1 equals 2x. The x's are going to cancel. X squared plus 1 equals 2x. If equal to 0, x squared minus 2x plus 1. And then this is when we factored earlier, right? What multiplies to 1 and adds to negative 2? Something similar to it. X minus 1 minus 1. So x equals 1. Okay. What would happen if I put 1 into that first fraction and I started to check my answer? I would have essentially a whole or a vertical asymptote if we were to look at a graph that was similar to this, right? So you get a 0 in the denominator. If I plug it in right here, 0 in the denominator is bad. This is like a domain restriction, right? I can't use 1 or negative 1 in the denominators in this fraction because I'd be dividing by 0. It is possible in a rational equation to get what's called an extraneous solution, a solution that works mathematically until we go back and check it. So we solve correctly, we get an answer, but it actually gives us, it's a restricted value in the equation. So what we do if this happens, and this is why it's important to check your answers, is we throw it out. We label it extraneous. Sometimes you'll have two solutions and both of them will be extraneous. Sometimes just one will be extraneous and the other one won't be. But any solution that would give you a 0 in the denominator, we throw out. Now, because that is our only solution for this problem, and I don't have anything else left, the answer to this problem is no solution. So if you were doing this like on a test or a quiz, you would say x equals 1, and you would label it extraneous, and then you would say no solution. Okay? Questions on that one? All right. I think this is our last problem for today. I think. Yeah, it is. All right. It's a short lesson. You guys are going to have some Math Excel work time today. Let's do this one. 6 over 2x minus 2 minus 1 over x plus 1 equals 2 over 2x plus 2 plus 1. There's a lot to unload here. All right, so I'm going to do a couple things to make this nicer to look at. I'm going to try to factor anything I can in the denominator. If I factor my denominators, it'll be less I have to worry about as far as like a common denominator later. So what can I factor out of that denominator? A 2, and that would leave me with x minus 1, okay? Then I have a minus. I don't love that, so I'm going to put plus a negative 1 on top over x plus 1 equals 2 over, again, I can factor a 2 out of that bottom, x plus 1 plus 1 over, I like everything to be a fraction, so I'm just going to say 1 over 1, so I can see those denominators I want. Okay. In that first fraction now, what can you do? Just that first fraction. Yeah, you can do 6 over 2. 6 divided by 2 gives me just 3 over x minus 1 plus negative 1 over x plus 1. And then you can do the same thing in this one. 2 over 2 just gives me 1 over x plus 1 plus 1 over 1. So what is, in this problem, the least common denominator? Now that I've made it a little prettier. Least common denominator.
X minus 1, x plus 1.
Yep. Okay, so I'm going to let you guys try to finish it now. So your choice. You can either get that common denominator on everything and then multiply by both sides, or you can try just multiplying each fraction by that common denominator and canceling things as they occur. See if you can solve it. All right, I'll give you a few minutes, and then we'll put the answer up and check it. Look at our answers. Okay, so I prefer, so it doesn't get messy, just to take that least common denominator and multiply it through. So if I multiply it through this first fraction, the x minus 1 cancel, that leaves me with 3 and x plus 1. If I multiply it into the second fraction, the x plus 1's cancel, leaves me with negative 1 and x minus 1. Through the third fraction, the x plus 1's cancel, leaving me with 1 and x minus 1. And then here, nothing would cancel, so I just have everything in my numerator. Distribute your negative, nothing to distribute. And then here you have to FOIL with their conjugates. So outside, inside cancel, you just left with x squared minus 1. Clean it up a little bit, combine my like terms, get it equal to 0, factor it, solutions, and neither of these would give you a 0 in the denominator. And you can look at the reduced equation or the original equation, it doesn't matter. No extraneous solutions, so both of those work. Don't have to throw anything out at the end there. What questions do you have on rational equations?
So you said you could plug like the 3 into the 2x plus 4 equals x squared plus x minus 2. Did you say you could do that?
Wait, where was the 2x? Oh, not here. Well, you can plug it in there, but that's not going to tell you if it's extraneous or not. I can plug these in anywhere, and it should work. But where I want to look to see if it's extraneous is where I see denominators. Where a denominator equals 0 is going to tell you if something's extraneous. So if I had like an answer of 1,
Yeah.
that would give me a 0, and that would be extraneous. Or if I had an answer of -1, that would give me an extraneous answer. But those are the only 2 like domain restrictions we have. So these aren't those, so I don't have any extraneous answers. So you want to look where those denominators are. Okay? Other questions for me on rational equations? That's it for the lesson today. All right, so if you want to get started, you guys have 20 minutes now. Your Math Excel, like I said, is kind of 2 parts, 1-5 and 1-7. You can do all of the fraction equation problems. If you get to an absolute value problem, just skip it, and we'll do those tomorrow. You can come back to them. Okay? All right. Time to work is yours. I'll do cell phone Lotto. That is it. 2. This Math Excel is due on Friday, by the way. Due on Friday. Yes. Mm-hmm.